Alrighty. Now, I'm going to go off here kind of like a little different than what I usually do. I'm going to try and make this as detailed as possible for the podcast only people, right? So today, I was thinking about let's do a podcast about networking. Those who are into networking, how do you learn certain aspects of the networking? So those who are looking to get themselves in the door or already in their way, like in the field, trying to get their way through their training or going to the education, doing their certification route, or doing the traditional college. There's a lot of features inside networking that a lot of folks don't talk about. And if you're looking to upgrade your skill set to become a cybersecurity professional, there's certain part of networking that you need to know. One of them is subnets. So when you do an IP addressing, Internet Protocol addressing, this is the thing that allows computers and devices, IoTs, anything that needs a network connection to function, like the internet. This is how this communication is done. It's done through the Internet Protocol layer of the OSI model, okay, which is the network layer. So in order for a device to connect, it has to have a network address. So what we call that network address, it's like a octet. It's four of them. This is for IP version 4. Now we're on 6, which uses hexadecimal. A lot of computers and legacy devices do not like IPv6, and a lot of big companies don't really use it for their internal networking schemes, but more on the outside for the big networks and like your wide area networks, your metropolitan area networks, things that involve more than 1,000 devices. You put them in the IPv6 subnet, but for users that are less than 1,000, you want to have a very manageable system for your network. And people use IP version 4. So, part of that IP version 4 I want to talk about is the subnet, which is kind of like the administrative boundary of the addressing scheme. So, we're going to talk about Class C networks, which a Class C IP subnet is based on the number of bits that are turned on. So, I have a spreadsheet that I was working on. You guys can do the same if you want. So you start off at the top of your spreadsheet with exponents, okay? It's going to make sense once everything is all situated. I can give you guys like a very visual look at what I'm talking about if you're doing the same thing I'm doing. Okay, so if you're not near a computer but you're listening to this on a like you're at work or something, or you're in the car, you could replay this. So this is gonna be an audio only podcast. I'm not gonna put any videos up. I just want to try and put a picture in your head. So imagine the first top part of your Excel spreadsheet. It's gonna have exponents. And you're going to use the caret symbol for your exponents, okay? The caret symbol is the little one that's an arrow pointing up, okay? It's like the greater than, less than, but it points up. It's the number 6 on your key. If you hold shift and hit 6, it'll show you that. So I'm going to speak in exponents for the next series of numbers. So you want to write from across the first row, A through H on your Excel spreadsheet, or whatever you're doing. Doesn't matter. You can even write it down just in the first row. 2 to the 7th, 2 to the 6th, 2 to the 5, 2 to the 4, 2 to the 3, 2 to the 2, 2 to the 1, 2 to the 0. Okay. Right next to it, write bit, because that's the value of the bit that we're going to use, okay? That's the bit. The second row, you're going to, from right under those exponents, you're going to write these series of numbers. You're going to write 128, 64, 32, 16, 8, 4, 2, 1. Those numbers are the values of those bits in each section. So what we did was we took a subnet. If you took all those numbers and added them all together, okay, you would get 255. All right. The thing about how computers read those numbers is that you're going to actually include the number 0, and you're going to include all the way to 255. So that's 256 digits. All right, that's the total value that a computer network can read per bit. So 8 bits is 1 byte. Okay, and that 1 byte, you can only read 255 characters can be seen, but in total, the value of the entire byte is 256. So when you look at a subnet, a subnet value of 255.255.255.0 is literally a 1 put on every single value underneath that those bits. If you turn on that bit, which is a 1, because binary numbers we're talking here, you only have a 0 or a 1. If you turn it on, then that value is placed there. So if we turn them all on, we get 255. And that's why in their subnets, whenever you're doing your IP addressing, you can look on your phone right now. You can look on your computer by right-clicking on your this PC and looking at your network and sharing center. You can type network and sharing center in your search, or you can click on the properties of your connection if you're using home Wi-Fi and all that. You can get the value of those bits. So a lot of internal networks, let's say for home and office, right? Small office and home. They use the Class C address of 255.255.255. We can say all this very, very easily by just using what we call a /24, which is called a CIDR notation, CIDR for short. CIDR means Classless Interdomain Routing Notation. This is how I'm going to be speaking from here on out. /24s. So our Class C subnets are /24, and how we look at this on a subnet for the Class C networks. Usually the address scheme is 192.168.1.0 for the network ID, or it's 192.168.0.0. But the number before that last 0, it really doesn't matter. What matters is this. Whatever number you're using, those first 3 digits are your network ID. The last one is the number of hosts you're going to put. And that's where the subnet comes in, because the subnet's going to dictate how many hosts are going to be allowed and how many networks are going to be allowed. So this is where it gets interesting, okay? So if you have a 192.168.1.0 network ID, then your subnet is going to be 255.255.255.0. That's your subnet. Or you could say /24. So you could literally write down 192.168.1.0/24 for your CIDR notation. So there's a formula to dictate how many hosts will be allowed per subnet. It's a very easy formula, but if you're not familiar with networks, you're not familiar with Cisco networking, it's going to be confusing. But I'm going to make it as simple as possible. You can write all this down. It's very simple, because what I'm reading to you right now is everything I wrote down. Okay, so you can write right below this labeling here. Okay, you could write down subnet /24. So I would give yourself a good amount of space. I would say about 4 spaces down before you write /24. Okay, so subnet /24, We're going to write 192.168.1.0 all in a row, and then right after that, write network ID. And then right below that, 255.255.255.0 subnet. Okay. Then under that, write available hosts. Formula is 2 to the n minus 2, which the n is the number of hosts that is maximum that could be allowed on there. So the n is like, what's the maximum number of digits in that subnet? All right, it's very simple. For the /24, so you could put if subnet is /24, then the number of hosts is 254, and the subnet address is 255.255.255.0. Why is this? It's because the total number of digits is 256. But if we use the -2 in there, you subtract 2, it becomes 254. Okay? So right below that, everything I just said, if you're writing it down, right below that part, give yourself a little space, and you're going to write network ID address is 192.168.1.0. The first address to use is 192.168.1.1. The last address to use is 192.168.1.254. The broadcast address is 192.168.1.255. First thing to note is the first address you're not using is the .0, and the last address you're not using is the 255, because one is the network ID and the last one is the broadcast. Broadcast is always 255 on there. It's always the last available address that you could put. That's broadcast is how the routers talk to each other. They talk to each other on the broadcast network. So that's always the last bit inside of a subnet. Okay? Now, what you could do also, so you can look at things in another way, is you can also reverse this top part here that has the values. Right below that, where the values are for your bits, you can literally reverse it, and you can use this formula for the number of networks per subnet. Okay, so if you took, without using 2 to the 0, all right, you kind of put a 0 under that. Just put a 0 there under your 2 to the 0, which is a value of 1. Okay, you want to take from the 246, the 248, 16, 32, 64, 128. You can literally flip that around. Take the 2, put it under the 128. Put the 4 under the 64. Put an 8 under the 32, 16 under 16, 8 under 32, or 32 under 8, 64 under 4, 128 under 2. This is the number of networks that could be created inside of each one if you were to turn on those bits like that. Okay? So again, if you turn the bit on, that's the number of networks you're going to create. And the way that it works is that row, you literally, if you turn on a bit, you're adding those numbers together. So let's say if you had a 1 and then a 0, 0, 0, 0, 0, then it's 128. If you had a 1, 1, then 0, 0, 0, 0, 0, 0, okay, it's 192, and so on and so forth, okay? And that's how those bits, when we apply them to our networks, we're reducing the number of hosts that we could put on there, but we're increasing the number of networks we can create per subnet, okay? And that's called segmentation, and that's what subnetting is all about. It's taking a large network and making it smaller through network segmentation. And network segmenting is actually very preferred and recommended as a cybersecurity professional, because it's a good way to keep those boundaries of your network boundaries separate, which means you have to have more routers inside of your network. That's a thing. You need to have those, but the subnets create that administrative boundary between them. So there's a buffer in between. Unless you know that address, you can't really get access to it. And that's how subnetting works. It's very effective. Let's say you get a large address and it's like a public one, but you can't use all of the addresses. So you want to make it finite. You want to reduce that so you can increase the number of addresses. Oh, sorry, excuse me. You want to increase the number of addresses you could use internally rather than externally. A lot of people use what they call is network address translation. I can put that on another podcast for another day. But primarily what we're talking about is private networks, networks that are internal that are non-routable. So if we were to go ahead and break up that 254, that 255.255.255.0 network, that's a pretty big network, 256 digits with 254 hosts that we could put on each of that subnet, right? It's a lot of numbers. There's a lot of hosts, but we don't want to use that many. Let's say we only need 126 or 120. This is the number of devices we're going to connect. So we don't want to use that other size. It's just too large. So we want to reduce it, make it smaller. You can do what's called subnet of, you can subnet that network. You can segment it a little more. So we'll split it into two. And here's how we'll do it. So let's say we have a sales department and we have our HR department, and we want to keep those guys separate, but on the same like numerical subnet. You break the network down into two. So how we're going to do that is we take a CIDR notation of 25. So we're going to go ahead and add a bit to our subnet. So how you do that is you take the 24, add a bit. And how do you do that is that you change the subnet address. From the .0, you put a 128 at the end. And why would we do that? Well, because we're going to take that network and we're going to go ahead and just make it smaller. And how we're going to do that is by doing this. When you're writing your CIDR notations of 25, let's say you're on a router, and your router's asking you for your subnet. So the router's going to be the one giving the addresses too. Sometimes it's like a layer 3 switch, which is your router with a switch. So we want to go ahead and say, okay, subnet's 25. So what we do is in the subnet section, we write 192.168.255. 255.255.255.128, and then our network ID that we're going to use is 192.168.1.0. Okay, that's network number 1. So what's going to happen is, because of the formula, because we borrowed the bit, our first address that we're going to use is 192.168.1.1, but our last address is 2 to the n minus 2. So if it's 128, we subtract 2, and that gives us 254. Okay? 254, my gosh. 128 minus 2 is 126. Okay? So that's our last available address that we can actually put for a host. Then our broadcast address now becomes 192.168.1.127. So again, network ID is 0. Broadcast is 127. In between those two numbers, that's the number of hosts. So then the network number 2 goes for our HR department, because our sales is taking the first subnet. So the second network ID is going to be 192.168.1.128. Okay, that's going to be the second network that we're going to use. The first available address inside of that one, that network ID, is 192.168.1.129. The last address we can use is 192.168.1.254. Broadcast is 192.168.1.255. Now, you should see a pattern here, because that pattern never changes. As of right now, that's how we've been doing it. It's been done this way for a very long time, and it hasn't changed. It's all numerical values. It's all calculated by the PC. How to read this in binary format for networking. It's always been this way. It's very effective if you have large networks and you want to break them down to smaller ones to make it more easy to manage and administrate as a network admin. Now, I'm going to read you all the official definition of CIDR notation. Okay, it's called Classless Interdomain Routing. It is an IP address allocation method that improves data routing efficiency on the internet. Every machine, server, and end user device that connects to the internet has a unique number called an IP address associated with it. With that IP address, when we're using CIDR notations, it's pretty much giving the administrative boundary of that network. And that's what I just wrote to y'all, okay? Or I just explained to you, sorry. So, this method can also be applied to other classes. We have a B, and a C. I didn't talk about A or B because they're too large for the scope of what I'm trying to show y'all. Rather show you class C because then you can just expand from there. You could just do the same principles of your class C to class A and B just on a larger scale. Same formatting, okay? So non-writable IP addresses for A is 10.0.0.0 to 10.255.255.255. The CIDR notation for it is 10.0.0.0/8. That's the CIDR notation. Okay. For class B, it's 192. Class B is 172, not 192. 172.16.0.0 to 172.31.255.255. Again, it's 172.16.0.0 to 172.31.255.255. CIDR notation for that one is 172.16.0.0/16. If you notice, they're going up by 8. And we already know for a class C, right? But the class C ranges are 192.168.0.0 to 192.168.255.255. CIDR notation is 192.168.0.0/24. So again, for the B, you have that range. Inside that range, you have all those addresses you can put up to that limit from your 2. So you can take any numbers in between those and make those your network IDs. And then using your CIDR notations, you can increase or decrease the number of networks or hosts that you want on your network. Always best to you segment your networks based on the needs of the business that you're using. So let's say you have less than 100 users. You don't want to use a Class B network for 100 users. All right, you don't want to use a Class A network for 100 users. You preferring for easy manageability and also for simplicity purposes is you use a Class C network for anything less than 270 users. I mean, if you have more than 254 users, then you definitely want to use a Class C network, but you want to use a Class C network taking a bit, but like they call it borrowing bits. If it's over 1,000 users, you want to use a Class B network. If it's over 1 million users, then you go ahead and put in a Class A network. But in that Class A network, if it's over 1 million, you definitely want to have a multiple router situation going on there, because you still want to break down your networks in a very manageable way, because 16 million users usually doesn't work, and 4 billion available addresses, that can get pretty lengthy. So keep that in mind. the maximum addresses inside of a Class C is like 4 billion. So you want to keep your addressing schemes in a very manageable way. Just for simplicity methods, just segment them as much as possible. Class C is a very easy way of doing it. A lot of people like to use Class B in the medium to large size networks because you get 16 million anyway. So a lot of people they're cool with that. I don't mind that either. It's also manageable as long as you know each addressing range inside of your network or organization. All right, so wrapping up, guys, I wrote all this down in a spreadsheet. As I was reading it to you is the way you can write it down. Give yourself some space in between. And if you have any questions, you can always follow me on Twitter or X now. So it's x.com/BVaz711. BVaz711 is my handle. It's my personality. It's my brand. So you're more than welcome to look for me, and you can send me emails and all that. It doesn't matter. Just headline your request with a subject saying that you listen to my podcast, and it's a question that you have on there. I was an IT trainer. I was a Microsoft trainer, so I do have experience in training folks. If you guys are interested in learning more about this stuff, or you have an interest in expanding a little more in there, I can. I would figure I'd give you a little bit of background on this and give you some insight on this is how professionals look at networks, especially if you're looking to go into the cybersecurity world. Again, I'm BVaz711. You guys take care, and this is the Random Convo Podcast, episode 4. We're keeping it going, y'all. Once a week, bring y'all content, and you guys take care, and I will see you in the next one. Till then, peace.